Hi everyone, welcome back to Bimklue Revit tutorial. Today I'm going to show you how to model the pneumatic pump and its pneumatic tank. And in addition, I'm also going to show you how is the pneumatic pump and the pneumatic tank function together. Okay, so today we're going to learn two things here, the modeling part and the basic concept of this functional concept of the pneumatic pump. Okay, I need to introduce again. This is our homepage. Here you can find out our courses. Here we have fire protection, swimming pool, electrical, and many more. Yeah. So when you scroll down our homepage here, we have a little bit explanation of our homepage, and these are all the courses available over here. So of course you can see the prices here, all available listed down over here. Then it's quite cheap compared to the market price here. So if you want to search the normal courses online, so this is basically the range of the courses. I have a look on it, so it's quite reasonable. This is what the market is asking for, yeah. So of course, if you are saying that there's quite a few students that asking me to lower down the price of the course. So if you see this course compared to the market price, you can see obviously this lower, way more lower, yeah. So when you click into the course outline, you can see these are all the basically course outlines, detailed step-by-step courses that you can learn from, actually starting from basic without nothing to advanced modeling skill. Okay, after going through all the courses over here, you can claim yourself as basically an expert in Revit modeling. Then of course, what is the advantage of our course compared to the market? Then this is project based. Then if you want to take the courses outside the market, then one thing you must be careful is what kind of outcome you are wishing for. And basically, there are a lot of cases where the student pay for high cost fees. Then at the end of the day, after finish the course, they are not be able to produce a model and piping system for the real case of the projects. Yeah, so it's not for our course. We're going to teach you project-based how to model each of the equipments and how to connect all the pipes based on the industrial practice and my construction experience. Okay, so this is the main difference compared to the market available courses. So these points must be careful. So if you pay such a low cost fees, then you can easily earn it back in your future through your career. Okay, so you can, after learning all the courses, you can basically realize your difference compared to the other people. Surely more advanced compared to other Revit professionals in the market. Okay, so you have no regrets on it. Okay, for sure. Time is money. Okay, without waiting more, so please enroll now. So first of all, why we need the pneumatic tank? Okay, normally if a pump without a pneumatic tank, so when the pump is running, pumping out the water and the water is stopped, right, then the air will start going into the pump shaft. Okay, so when the next time you're going to turn on the water tap to drain off the water, then air will be trapped inside the shaft, yeah, the pump shaft. Then when the pump rotates, then it won't be able to pump out the water effectively because the air trapped inside here and block the water flow. Okay, so with the function of a pneumatic tank, so when the water is drawing from the water source and it's going to be stored inside a tank called pneumatic tank. Okay, so the water going to be pressurized inside here, then so will be stored here for a moment. Okay, so when the next time you turn on the water tap to drain off the water, so the water going to be pressurized and the air won't trap inside this pump shaft here because there is water going to be compensate to the drain off of the water from the water tap. So the concept is very basic and easy to be understand. Okay, so water coming in here will be stored inside here and then will be compressed until pressurized with the air over here. Then when the water tap is on, then the water going to be pressurized and flow out instead of drawing the empty air from the pump shaft over here. Okay, so that's how the pneumatic pump function. So the next part is we're going to learn how to model this. So I'm going to randomly choose one model from the online resources. So this is the tsunami pump that very commonly used pump. Okay, so basically people we're going to install on the rooftop for their domestic water tank, household domestic water tank. Yeah, so this is the basic information for this pump. So this is the dimension of the pump. Okay, so we're going to start over here. So first of all, open Revit. Any template will do. We're going to model the family of the water pump. So first of all, new family. Then we're going to start with mechanical equipment. Okay, you can also start with generic model. Then after that, you can assign it as a mechanical equipment also. Okay, or you straight away start with this is also okay. So go to press open. Then first of all, observe the shape of the pump. So we basically need a rotation to form the body of the pump, and a shaft and a pneumatic tank. Okay, and the junction box and some pressure sensor here and the pressure gauge over here. So that's not very important. Basically, we come up with a general shape of the pump first. Okay, so here understand the dimension of the pump first. Yeah, we're going to check. 400 is the length, 270 is the width, 670 mm is the height. Okay, so we're going to draw some reference line over here first. We can use the model line. So first of all, we know that the length is going to be 400. Then the width going to be 270. Okay, so this is the guideline of your modeling. First, place it over here, then move it to the center. Okay, so from the front view, you can have a line, create a line here about, let's check again, 670 for the height, 670. Okay, so this is the top height limitation of the pump. Yeah, so next, create a rotation by using a revolve tool. So makes the first revolve. We're going to refer to the shape of the pump here. Carefully see, observe the shape of the pump. Okay, so start with okay, this is a line. Yeah, so start with 1. Okay, the tip of the pump. Okay, then this is the end of the pump. Yeah, 400 is the end of the pump. Okay, if you feel very difficult to rotate over here, you can just model it from the reference level here. You can see the lines. Okay, so make a revolve over here. Okay, now it's better. So the tip of the pump. Then of course here we're going to have some curve shape. Okay, until here, roughly about here. Then another joint, which is the header of the pump together with the body of the motor. Yeah, so around here we do let's make it to the half of here. Okay. Then the curve shape, we can use this function, fillet arc, curve to form the curve shape. Okay. So then we complete our first revolve the axis line. Okay. Done. Yeah, the 3D shown like this. Okay. Of course, it's not, you need to adjust the height later. Yeah. So next one, the body of the motor. Yeah, here behind. Okay. Obviously, it's roughly about a square, but it's not square. It's, okay. So we're going to model it from the left side. From the left is around here. Create an extrusion here. So about let's do it about 200. 200 is too high, yeah? So not exceeding this, so it's 170. So 170, that makes it at 150, slightly smaller. Okay, then you can have a curve like this. Then you just mirror this to the other side. Okay, then mirror this to the other side too. Then here, mirror this to the other side. Okay, then of course you're going to finish off the lines over here. Just drag, or you can use the trim tool to complete this task. Yeah, delete the outer part of the reference line. Of course, you can make it as a curve shape again. 15 mm is okay. The radius, yeah, 15 mm radius. 15 mm, but it depends on how detailed you want it to be. Yeah, it's not a must for you. If you require a very high detail level of detail of the model, you can model it to extreme detail and exact dimension. So of course here will be sufficient. Then from here, you're going to drag this to here. This is behind part of the pump. Yeah. So here will be a slightly smaller rectangle. Yeah. So from the left side, create another one here. I'm going to use the extrusion this round. I'm going to pick the lines. Okay. I press the tab 2 times, yeah, so I can select the outer reference line. Okay. Then I'm going to scale it. Select it to scale it down. I'm going to use this scale to scale it down until 0.8. Then I press it over here. Finish that. So from the reference level, I have another rectangle over here. Now, the cooling fin. Of course, you can do your cooling fins over here. Going to create extrusion, little cooling fins, just like this. 2 mm. Just do a little bit of fins. Okay, then you just copy it to the other side. Okay, no. Slightly pull it down. Copy to the other side, like 10 mm will do, just some representative of your cooling fins. Okay, move this down. Another one will be sufficient. Okay, put this down. Okay, then mirror this to the other side. Okay, to form the extrusion. Then mirror this to the other side. 2. Then similarly, here, and the bottom part of it. Okay, finish that. Then from the reference level, we're going to pull these cooling fins up to here, and here will do. Okay, so the pump will be like this. So very quickly, we have a general shape of the pump now. So next one, we're going to create we're going to move that up first. Okay, move it to the correct position first. Like we're going to copy this. Okay, you can try to move, yeah, but use the selection filter over here. I don't want to move the lines. I just want to move this mechanical equipment. So move. If I try to move and remove the constraint, then you can start to move about around here. Okay, some portion it didn't move together, so you can use the copy function to copy it to here. Then you delete the original one. Okay, so next one, we're going to create a bracket below here. From the left side, going to create something like a similar extrusion. Simple one will do, yeah. Then from here to here, then here, then just mirror it to the other side. Okay, simple. From the front, this bracket will be like this, supporting here. Let's check the image. Okay, supporting the motor instead. Okay, move it up to here. Then from the reference level, we're going to do the footing of the pump. Just roughly become like this. Okay, to move it up to the center. Finish that. From the front, move it down. So this is the base plate of the pump. Okay, then if you have time, then you can fine tune it to the shape you want, to diagonal support here. Of course, you can add it by using the extrusion method. Okay, so next one, I'm going to use the revolve tool again to create this revolve for the pneumatic tank. Yeah. So from the front view here, so this is the limitation height. Okay, so we're going to create and revolve here up to here. Then of course, if you have two separate material, you can just separate doing two revolve separately. But due to time constraint, I'm going to combine it to one. Okay, so the pneumatic tank roughly become like this. Some groove line. Okay, until here. Then the remaining parts is the connection parts of the sensors and the outlets. So this is the water incoming, yeah. The outgoing should be somewhere here. Okay. Let's check it out. Yeah, it's capped already somewhere here. Okay. So of course, now complete it with the curve line. Curve line. Okay. Then the axis line. Finish. Okay. Okay, if this too large, then of course you can move it inside. Finish. Okay, that sounds better. So from the 3D view, now this is the shape of your pneumatic pump. Okay, very quickly, you finish the general shape of the pump. Now the gauge. From the left view, of course, you can create an extrusion over here to represent the yoke gauge. around here will do. Then another one to represent your outlets is over here. Then another one is the sensing device, the pressure sensor. The pressure sensor, another one here. Just have a general shape here will do. Okay, so the next task is you're going to move this and adjust all the extrusion. Okay, so it's over here. This will be the pressure gauge. This will be the outlets of the pump. This will be the pressure sensor, if not mistaken. Yeah. Check it out in 3D view. So that's okay. We are correct. Then from the front view, doing the connection over here, simple extrusion will do. Done. Then from the left view, connect it to here. Okay, just connect it together because we're not looking at very detailed modeling. Detailed modeling need time, yeah? So that's done. So it looks like it's not balanced. I'm going to do another support again from the front view. So copy this to here. Okay, much more better. Then the remaining parts is a junction box for the electrical connection. So just model a square will do, yeah. Rectangle. Then become a junction box by pulling it to become an extrusion. Okay, so next one. Okay, looks like we are done with our pneumatic pump. Okay, so can delete the lines. So change to shaded parts. Okay, next one I'm going to create a pipe connectors. Pipe connectors is important for you to start to model your piping connection from the pumps. Okay, so click this face here. This is the inlet. Yeah, diameter 25 mm. Okay, this is, of course, is a domestic cold water, and this is in water flowing in to the connector. And then another one here. Then this is 25 mm too, and this is domestic cold water, and this is water flowing out from the connectors. Then next one is electrical connectors. I'm going to put this on here, on this surface over here. Then of course this is a power device, and this is single phase. 230 is for some countries. Some countries not 230 for the single phase supply. Then you have to key in your country's standards. Yeah. So this is single phase. Power 370 watt. 370 watts. This is apparent power. Yeah. So this is real power. So if the power factor is 1, then here is 370. Okay, if there's any power factor applicable, then you can change it to slightly lower, like times 0.9. Okay, that's done. So this is your pump. Yeah. Then next one, key in all the information that you want. Of course, if you don't want to lose the information here, just copy this first URL, paste it over here. So next time you can straight away click here to access your URL link. Okay. Then apply. Okay. Then load inside to your project. Okay. Okay. Save it anywhere first. Save. Okay, put it here. Then you can start to draw your pipes. Draw pipes. Standard pipes. Fine. Okay. The 3D view looks like this. Okay. So if you import it into your project file, make it shaded, when you click your family, you can have the detail of the connectors here, showing the power, voltage, and water in and out. Yeah, of course you can try to connect it again to here. Okay, further complete your piping connection. So, okay, today we learned two things: the functional concept of the pneumatic pumps, and the next one is a quick modeling skills to create the pneumatic pump family. Okay, I guess that's all for this session. Thanks for joining.